Hello students, last class we learned about the function and classification of ultrasonic detectors. Today we will introduce common ultrasonic detectors and their working principles. Through the learning of this course, the following teaching objectives should be achieved. 1. Master the working principle of A-type pulse reflection ultrasonic flow detector. 2. Master the main bottom function of the ultrasonic detector panel. In the following, we take the most widely used A-type pulse reflection ultrasonic flow detector as the example to introduce its general working principle, as shown in the figure. Each part of the instrument is represented by the box, and the boxes are connected by lines to indicate the relationship between the various parts. As can be seen from the figure, the ultrasonic detector is mainly composed of the following parts: synchronous circuit, scanning circuit, transmitting circuit, receiving circuit, display element circuit, and power supply circuit. When working, the synchronous circuit first generates a trigger pulse to the scanning circuit and the transmitting circuit at the same time. The scanning circuit is triggered to start working, generating a sawtooth wave scanning voltage, which is applied to the horizontal deflection plate of the oscilloscope to make the electron beam deflect horizontally. A horizontal scan line is generated on it. At the same time, the transmitting circuit is triggered to generate high-frequency narrow pulses, added to the probe to excite the piezoelectric waver of the probe to vibrate, and ultrasonic waves are generated in the workpiece. The ultrasonic wave propagates in the workpiece. If it encounters defects on the bottom surface, it will generate reflected echoes, which will be converted into electrical signals by piezoelectric chips, amplified and detected by the receiving circuits, and applied to the vertical deflection plate of the oscilloscope, that the electron beam is deflected vertically. Defect waves or bottom waves are generated at the corresponding positions of the horizontal scan lines. Therefore, the barrel depth of the defect can be determined according to the position of the defective wave, and the size of the defect equivalent can be estimated according to the amplitude of the defective wave. The specific functions of each main circuit are as follows. The synchronous circuit is also called the trigger circuit. It generates dozens to thousands of pulses per second, which are used to trigger the scan circuit and transmit circuit of the flow detector, so as to make it consistent and orderly work. Therefore, the synchronous circuit is the hub of the entire flow detector. The transmitting circuit receives the trigger of the synchronous pulse and generates high voltage electrical pulse of 100 to 1000 volts, usually no more than 400 volts. It is usually required that the frequency band range of the transmitted pulse should include frequency band range of the probe itself, and use resonance to generate ultrasonic signal. The wider the frequency band and the narrower the transmit pulse, the better the resolution will be. Adjusting the emission intensity knob or damping knob on the instrument panel can change the emission voltage, pulse width, and emission energy, which in turn affects the ultrasonic penetration, dictation, blind spot, and resolution, etc. The receiving circuit consists of an attenuator, a radio frequency amplifier, a detector, and a video amplifier. It amplifies and detects the electrical signal from the probe, and finally adds it to the vertical deflection plate of the oscilloscope and displays it on the screen. Usually, The received electrical signal is only hundreds of microvolts to several volts, and the required voltage of the vertical detector plate is several hundred volts, so the receiving circuit must have the amplification capability above more than 10 million power. The process is shown in the figure. According to the strength of the received signal, the magnification can be adjusted by the attenuator. Generally, the voltage magnification of the amplifier is expressed in decibels. The scanning circuit, also known as the time basic circuit, as shown in the figure, is used to generate a sawtooth wave voltage, which is proportional on the time, and added to the horizontal deflection plate of the oscilloscope tube to make the light spot on the oscilloscope tube screen move at the same speed in the horizontal direction to generate a horizontal scanning baseline. The depth of course adjustment, fine adjustment, and scanning delay knobs on the panel of the floor detector are all control knobs of the scanning circuit. The display circuit is mainly composed of an oscilloscope tube and peripheral circuits, the oscilloscope tube used to display the floor detection patterns. The oscilloscope tube consists of three parts: the electron gun, the reflection system, and a phosphor screen. Its basic structure is shown in figure. When the bunched electrons emitted by the electron gun bombard the phosphor screen at a very high speed, the phosphor emits light and forms a bright spot on the phosphor screen. The deflection of the electron beam is controlled by the voltage on the horizontal deflection plate and the vertical deflection plate, so that the floor deflection pattern is drawn on the fluorescent screen. The function of the power supply circuit is to provide proper voltage to each part of the circuit of the floor detector, so that the whole circuit can work stably. In addition to the above basic components, the floor detector also has various auxiliary circuits such as delay circuit, DAC circuit, gate circuit, etc. Having known the basic principles of the ultrasonic detectors, let's briefly introduce the use of the main knobs on the panel of the floor detector. Take the CDS 22 floor detector as the example. In practical ultrasonic testing, the echo amplitude and its horizontal scale on the display screen often need to be adjusted. The corresponding knobs are mainly 5, 6, 8, and 13, 14, 15 in the figure. Among them, 5 and 6 are called attenuators, corresponding to two kinds of coarse adjustment and fine adjustment, which are completed in a stepwise manner. 8 is called the gain, which mainly realizes the continuous adjustment of the echo amplitude in a small range. 13 is called the depth range, equivalent to the dictation range. It is divided into three levels: 50 mm, 250 mm, and 1 meter, but it is not absolute, and the display effect shall prevail. 14 is called depth fine-tuning. In order to achieve expansion or compression of the echo level scales to maintain a constant ratio of mutual spacing. 15 is called pulse shift, which realizes the overall left and right movement of the echo on the display screen. Through the study above, I believe you can have a basic understanding of the basic principles, types, and usage of ultrasonic detector. Strengthen your practice in the future training and master the use of ultrasonic detector. Well, that's all for today's content. Thank you.